Welcome to Asia's Technology Solutions. Today, let us learn about SDLC Part 1. So, under SDLC, today we'll learn what is SDLC, Waterfall model, Spiral model, and then with V model. So, what is SDLC? Software development lifecycle is a process used by the software industry to design, develop, and test high-quality softwares. The SDLC aims to produce a high-quality software that meets or exceeds customer expectations, reaches completion within times and cost estimates. SDLC is the acronym of Software Development Lifecycle, which is also called as Software Development Process. SDLC is a framework defining tasks performed at each step in the software development process. ISO IEC 12207 is an international standard for software lifecycle processes. It aims to be the standard that defines all the tasks required for developing and maintaining software. While we understand SDLC is a framework that describes the activities performed at each stage of software development project, SDLC is a process followed for a software project. Within a software organization, it consists of a detailed plan describing how to develop, maintain, replace, and alter or enhance specific software. The life cycle defines a methodology for improving the quality of software and the overall development processes. The figure is a graphical representation of various stages of SDLC, which has planning, defining, designing, building, testing, and deployment. So let us understand what is lifecycle model. Lifecycle model provides a fixed generic framework that can be tailored to a specific project. Project-specific parameters will include size, budget, and duration. So by changing the lifecycle model, we can improve development speed, product quality, project visibility, administrative overhead, risk exposure, customer relations, etc. So let us understand what is waterfall model. The waterfall model was the first processes model to be introduced. It is also referred to as a linear sequential lifecycle model. It is very simple to understand and use. In a waterfall model, each phase must be completed before the next phase can begin, and there is no overlapping in the phases. In some respect, waterfall is a common sense approach introduced by Royce in 1970. The waterfall model illustrates the software development process in a linear sequential flow. This means that any phase in the development processes begins only if the previous phase is complete. In this waterfall model, the phases do not overlap. Waterfall approach was the first SDLC model to be used widely in the software engineering to ensure successes of the project. In the waterfall approach, the whole processes of software development is divided into separate phases. In this waterfall model, typically the outcome of the phase acts as an input for the next phase sequentially. The following illustration is a representation of the different phases of the waterfall model. Requirements defines needed information, function, behavior, performance, and interfaces. Design could be in terms of data structures, software architecture, interface representations, and algorithm details. Implementation could be source code, database, use documentation, and testing. While we have waterfall model captured here, the user requirements output would be in terms of user requirements document, and the software requirements output could be in terms of software requirements document. Architecture design could be the output in terms of architectural design document. In the next phase, is detailed design and coding could be in terms of the output of detailed design and code. The next phase of post-coding would be the testing. Testing and final would be the delivery of the software code. So it may follow with the swimming upstream. Now let us understand what are the strengths of waterfall model. Waterfall model is easy to understand and easy to use. It provides structure to inexperienced staff, milestones are well understood, sets requirements stability, good for management control, plan, staff and track, works well when quantity is more important than cost or schedule. Then what are the deficiencies of waterfall model? Waterfall model is idealized. It does not match reality well. It doesn't reflect iterative nature of exploratory development. Unrealistic to expect accurate requirements so early in the project. Software is delivered late in the project, delays discovery of serious errors. Difficult to integrate risk management, difficult and expensive to make changes to the documents because it is swimming upstream, significant administrative overhead, costly for small teams and projects. So then when do we have to use waterfall model? Waterfall model could be better used when requirements are well known, product definition is stable, technology is understood, new version of an existing product, porting an existing product to a new platform. Now let us go to the next model of SDLC, which is a spiral model. The spiral model combines the idea of iterative development with the systematic control aspects of the waterfall model. This spiral model is a combination of iterative development processes model and sequential linear development model. That is the waterfall model with a very high emphasis on risk analysis. It allows incremental releases of the products or incremental refinement through each iteration around the spiral. So when we have the design of the spiral model has 4 phases. A software project repeatedly passes through these phases in iterations called spirals. So mainly this adds risk and rapid application development prototyping to the waterfall model. Each cycle involves the same sequence of steps as the waterfall model. Let us understand the first quadrant. Determine objectives, alternatives and constraints. Objectives could be in terms of functionality, performance, hardware and software interface, critical success factors, etc. Alternatives could be in terms of build, reuse, buy, subcontracted, etc. Constraints could be cost, schedule and interface, etc. The next phase would be to evaluate alternatives, identify and resolve risks. So it would involve studying of alternatives related to objectives and constraints and to identify risks in terms of lack of experience, new technology, tight schedules, poor process, etc. And then go for resolving of risks. Evaluate if money could be lost by continuing system development. The next process or the phase in the spiral quadrant would be to develop the next level product. The typical activities would involve to create a design, review design, develop code, inspect code and to test a product. The next phase of the spiral quadrant would be the typical activities would involve develop project plan, develop configuration management plan, develop a test plan and develop an installation plan. So let us understand what are the strengths of spiral model. Spiral model provides early indication of insurmountable risks without much cost. Users see the system early because of the rapid prototyping tools. Critical high-risk functions are developed first. The design doesn't have to be perfect. Users can be closely tied to all the life cycle steps. Early and frequent feedback from users, cumulative costs are assessed frequently. Then let us understand the weakness of spiral model. The weakness involved would be to the time spent for evaluating risks for too large for small or low risk projects. Time spent planning, resetting objectives, doing risk analysis and prototyping may be excessive. The model is complex, risk assessment expertise is required, spiral may continue indefinitely. Developers must be reassigned during non-development phase activities. It may be hard to define objective, verifiable milestones that indicate readiness to proceed through the next iteration. So then when do we have to go use a spiral model? So spiral model is better to be used when creation of a prototype is appropriate, or when the cost and the risk evaluation is important for medium to high risk projects, long-term project commitment unwise because of potential changes to economic priorities. Users are unsure of the needs, requirements are complex, new product line, significant changes are expected in terms of research and exploration. Then let's understand the final SDLC model of this tutorial, that is V-shaped SDLC model. The V model is an SDLC model where execution of the process happens in a sequential manner as a V shape. It is also known as verification and validation model. The V model is an extension of the waterfall model and is based on the association of testing phase for each corresponding development stage. This means that for every single phase in the development cycle, there is a directly associated set testing phase. This is a highly disciplined model, and the next phase starts only after completion of the previous phase. So here, testing of the product is planned in parallel with the corresponding phase of development. So let us understand what are the V-shaped steps. So on the left side of the V, which is the verification phase, it involves the project and requirements planning, allocate resources, product requirements and specification analysis, where complete specification of the software system is performed. Architecture or high-level design defines how software functions fulfill the design. Detailed design involves to develop algorithms for each architectural component. And the right side of the validation phase involves the production, operation and maintenance, which involves providing it for enhancement and corrections, system and acceptance testing, where it involves to check the entire software system in its environment, which follows with integration and testing, check that modules interconnect correctly, unit testing to check that each module acts as expected. Nonetheless, it involves the coding of where transforming of algorithms into software. Let us understand the V-shaped model. So V-shaped model on the left side involves a verification, and on the right side involves a validation phase. So the left side, the first phase in the verification phase starts with the requirement analysis, and then goes with high-level design down the line, and next with a detailed design, and then with the coding. And on the right side it goes up towards the validation phase, which involves post the coding, where preparation for unit testing happens, and then go with the unit testing, and then proceed with the integration testing, system testing, and finally end up with the acceptance testing. While we see in arrows marked from requirement analysis, which involves preparation for acceptance test, and in marked with acceptance testing. Similarly, high-level design goes for the preparation of system test, and then go on the right side we have the system testing phase. Detailed design, which involves a preparation for integration test, on the right side we have the integration testing. And finally coding involves the preparation for unit test, on the right side we go for the unit testing of the phase. So this is also like the parallel activity happening from verification phase to the validation phase. Let us understand the verification phase in detail. So the first activity of the verification phase involves a requirement analysis where a user requirements are documented. Document will contain the functional and non-functional requirements of the system, which is SRS. High-level design requirements are analyzed to implement. Software specification document is created, which serves the basis for software development, which follows with the low-level design where modules are listed and functionality of each module is described. Dependence of each module is defined. Database design and integration testing design are carried out, which follows with the coding process where coding of the system is performed. Now let us understand the right side of the wheel, which is the validation phase. And the validation phase, it starts with the unit testing where modules or components are tested separately, and it is done by developers. Integration testing performed after integrating the components of modules to find the defects due to integration between the modules, which again the testing may be performed by the developers. Test system testing to check if it meets the functional and non-functional requirements and dependence of each module is performed by the test team in an environment similar to production environment. Database design and integration testing design etc. are carried out. Finally, it goes with a user acceptance testing UAT to test the system according to the user and business requirements to check if system is ready for public use, and is performed just before implementing the system in the production environment and is performed by the business. So finally, let us understand the V-shaped model strengths. V-shaped model emphasizes planning for verification and validation of the product in the early stages of product development. Each deliverable must be testable. Project management can track progress by milestones, and this is easy to use. Finally, let us understand the weakness of V-shaped model. V-shaped model does not easily handle concurrent events, does not handle iterations of phases, does not easily handle dynamic changes in requirements, does not contain risk analysis activities. So under such circumstances, let us understand when can we go to use V-shaped model. V-shaped model could be an excellent choice for systems requiring high reliability. That applications could be hospital patient control, and when all requirements are known upfront, when it can be modified to handle changing requirements beyond the analysis phase, and solution and technology are known. That's all for this SDLC part 1 tutorial. Thanks. Let us sync up in the next tutorial. Do you have any academic project requirements? If so, you could reach us on the below connectors. You can call or WhatsApp on a number here, and also you could email at info@asiastechnologysolutions.in, asiastechnology@gmail.com. Thank you for watching this video. Please like and share this video. Thank you. Bye-bye.